Good one to all of you. Today we will discuss new subject. That is engineering thermodynamics. The subjects especially used for BTech first year BME students, BME subject, first year students, all branches, diploma students, and plus two science students, for JEE, NEET, for all students, the subject is very much useful. Today I will discuss theory. Next class I will do important problems related to this theory. Clear? Start. What is thermodynamics? So what is thermodynamics or engineering thermodynamics or engineering thermodynamics? The subject name is engineering thermodynamics or thermodynamics. Thermo means heat. What is thermo? Heat. Dynamics means motion or transfer. So thermodynamics means transfer or motion of heat. Clear? So this definition: the field of science which deals with energies possessed by gases and vapors. The energy which possessed by gas or vapor. Their conversion in terms of heat and energy. Clear? The relation with the properties of system. What are the property system? Pressure, volume, temperature. The property system. Heat, work. The relation, their conversion is called thermodynamics. Clear? So what is applied thermodynamics? Applied thermodynamics deals with such special applications of energy transfer as power generation, gas compression, etc. Clear? This is thermodynamics. So what is thermodynamic media? Media means through which heat transfer can takes place. Clear? Thermodynamic media. Thermodynamic media. Clear? Media means medium through which energy transfer can takes place. Clear? The medium through which the energy transfer can takes place. The energy transfer can takes place is known as thermodynamic media. Thermodynamic media. Clear? The medium through which energy transfer can take place. Suppose for IC engine, internal combustion engine, the medium is air and fuel vapor mixture. For steam power plant, what is the medium? Steam. That means steam is come from water. It may be liquid or vapor form. Clear? For refrigerants, carbon dioxide, ammonia, these are the medium for energy transfer. So this is called thermodynamic media. Clear? The medium through which the energy transfer can take place is known as thermodynamic media. Clear? For IC engine, the thermodynamic media is air and fuel vapor mixture. mixture. Clear? For steam power plant, steam power plant, the media is steam. Steam means water when starts boiling, it forms a steam. Both in liquid and vapor form. Clear? For refrigeration units, the thermal media is refrigerants. Refrigerants such as ammonia, carbon dioxide, etc. This is thermodynamic media. What is thermodynamic system? System. Thermodynamic media. What is definition of thermodynamics? Now I will discuss about what is thermodynamic system. Clear? Thermodynamic system. What is system? This is system. We are inside the room. The inside room is system. The wall of the room is boundary. Outside the wall is called surrounding. Clear? This is system. This is boundary. Clear? The outside boundary is called surrounding. Clear? So, inside the boundary, everything is called system. Outside the boundary, this is called surrounding. Clear? So, thermodynamic system refers thermodynamic system refers to any matter or group of matter within a prescribed boundary. Clear? So within a boundary, anything is called a system. Clear? Anything outside the boundary is called surrounding. Clear? Is called surrounding. So outside boundary, inside boundary. Inside boundary, within the boundary is called system. So outside boundary is called surrounding. Clear? Then boundary surrounding constitute each other, they form a universe. When or system and surrounding constitute each other or unit together, they form universe. Clear? Clear? So this is system, this is boundary, outside boundary is called surrounding. Now we are inside the room, this is system. The wall of the room is called boundary, and outside the room is called surrounding. Clear? Now what are types of system? Next. Next. Types of thermodynamic systems. Clear? This is three types. The thermodynamic system is mainly three types. It is mainly three types. Clear? Number one, closed system. Closed system. Outside, neither mass go to outside or energy or mass neither transfer to the system or from the system. Clear? Energy can transfer, but mass can transfer. Number two, open system. Number three, isolated system. Clear? Number one, number one, closed system. Clear? In the closed system, the boundaries are closed, no openings, no transfer mass, but energy transfer can take place. Clear? In closed system, the closed system, the boundaries are closed. The boundaries are closed, so that no mass transfer takes place. No mass transfer can takes place to or from the system. To or from the system. Clear? Suppose a pressure cooker will take example. If you put some fruits and the outside cover is closed and to give heat, the fruits can convert into curry, so heat can convert into work. Energy transfer can take place, but the mass remains constant. Clear? Since this is closed system, so the mass remains constant, but energy transfer can take place. Clear? So in this system, the boundaries are closed so that no mass transfer takes place to or from the system or across the boundary of the system. But energy transfer can take place. energy transfer can takes place at the at the boundaries of the system. Clear? No mass transfer, but energy transfer can takes place. Clear? And the process is called non-flow process. Process occurring in this closed system is called non-flow process. Because no flow, and the process occurs under this system. Under this system is called non-flow process. Non-flow process. Clear? What are examples of closed system? What are the examples? Examples. Pressure cooker. Clear? I gave the example pressure cooker. Similarly, bomb calorimeter. Motor car battery. Clear? These are the examples of a closed system. Next, number 2, open system. Two, open system. Clear? What's open system? There is some openings through which the energy transfer as well as mass transfer takes place to or from the system. Clear? In this system, the boundaries are not closed, but have one or more openings. Clear? Through which the mass transfer as well as the energy transfer takes place. Clear? This is open system, not closed. The energy as well as the mass transfer takes place. So the process in this system is called flow process. The process under this system is called flow process. Clear? What are the examples of open system? What are the examples? Examples are water wheel, clear, turbine, centrifugal pump, clear, nozzle, air compressor, air compressor, ice engine, etc. These are examples of a open system. Next, number 3. Number 3, isolated system. An isolated system is one which is not influenced by the surrounding. Clear? In this system, neither the mass nor energy transfer crosses the boundary of the system. Clear? So, what is the example? An open system with universe is example of that is universe is an example of isolated system. No energy transfer takes place to the system or from the system. No energy, no mass. Clear? The open system with the surrounding is called a isolated system. That is universe. Clear? Clear? Now this is thermodynamic property. What is thermodynamic property? The thermodynamic property refers to the characteristic which can be used to describe the state or condition of the system. Clear? For example, temperature, pressure, volume, energy, work, chemical composition. These are called density. These are called thermodynamic property of the system. This is mainly two types. This is mainly two types. Number one, this is two types. Number one, intensive property or intrinsic property. Clear? Number two, extensive or extrinsic property. Clear? Now, what is intensive property? Number one, intensive property. Clear? These are the properties. These are the properties which are independent of mass of the system. Clear? Independent mass. Suppose temperature. Number example, temperature, pressure. Clear? These are intensive property because when the mass increases or decreases, the temperature will not be affected or pressure will not be affected. If you take 1 liter water at 10 degrees centigrade. When we divide into two parts, so each part have equal 10 degrees centigrade. Temperature will not be affected. Clear? So the mass remains half 5 liters, but temperature remains equal 10 degrees centigrade. Equal temperature in both cases, in both parts. Clear? So the pressure also will not affect with increase or decrease of mass. So these are called intensive property, independent of the mass of the system. Next, extension property. Number two, extension property. Extensive property. Clear? What is the extensive property? This depends on mass of system. Clear? This is the property, or these are the properties. These are the properties which is dependent on the mass of the system. Clear? Depend on mass. For example, total volume, total energy, clear? Weight, total heat. These are external property, because if mass increases, the weight of the body increases. If mass increases, the volume of the body increases. If mass increases, the energy heat also increases. So these are depends upon mass. So these are called extensive property. Clear? Next, specific heat. See, specific heat. This is the quantity of heat. This is defined as, this is defined as the quantity of heat required to raise required to raise the temperature of unit mass of substance. The temperature of unit mass of substance, mass of substance through unit degree. Rise of temperature. Rise of temperature. Clear? What is its meaning? What is this meaning? This is, we know, the heat Q is equal to m into C into T2 minus T1. Clear? mc dt. What is Q is equal to m C T2 minus T1 or mc dt. So how to define this? Such heat, where C is equal to Q is equal to total heat. Clear? Q. What is M is equal to? Mass of substance or gas. Or C is equal to society of gas. Clear? What T1 and T2? Initial and final temperature. Clear? Q is equal to mc dt. This is dt. Suppose mc dt. dt means T2 and T1. Final temperature minus initial temperature. Clear? I will define what is C from this equation. This equation 1. See the blackboard. Specific heat. This is defined the quantity of heat. Means C is defined as Q. Quantity of heat required to raise the temperature of unity mass of substance m is 1 kg unity mass through unit degree rise of temperature. Clear? That means if m is 1 unit, dt is equal to 1, what is C is equal to? Q. The definition. C is equal to Q. Succeed is equal to quantity of heat required to raise unity mass of substance through unity rise of temperature. Clear? So what is unit of heat? Unit. Unit of heat. The unit of specific heat. What is Q? What is unit of Q? Kilojoule. Clear? What is M? Kg. What T2 and T1? Kelvin. Hence, C is equal to, what is C? Then, what is C is equal to? Q by M into dt. So what is Q? Kilojoule per kg Kelvin. Clear? This unit of heat. What types of specific heat? Types of specific heat. Clear? For liquids and solids, there is one such heat. For liquid and solid, there is one such heat. One such heat. Clear? For all liquids, every liquid has one such heat. But for gases, there are two such heat. Clear? Number one, such heat at constant pressure. Clear? Cp. Number 2, specific heat at constant volume, that is Cb. Clear? Now we will define what is Cp and what is Cb. Number 1, specific heat at constant pressure, Cp. Clear? What is Cp? Pressure constant remains constant. So it is the quantity of heat. It is the quantity of heat required to raise unit mass of substance through unit degree when the pressure remains constant. When the pressure remains constant. Clear? At constant pressure, this acid is called saturated constant pressure, Cp. If m kg of gas is heated from temperature T1 to T2, when the pressure remains constant, then the heat required, what is Q is equal to m Cp T2 minus T1. Clear? This is Q. Similarly, Cp set a constant volume, Cb 2. What is Cb? It is the quantity of heat required to raise the temperature of unit mass of substance, clear, through unit degree through unit degree when the volume is constant. Volume is constant. Clear? If m kg of gas is heated at constant volume, clear? From temperature T1 and T2, T1 to T2, initial T1, final T2, then the quantity of Q is equal to total heat Q is equal to m Cb T2 minus T1, clear? This is total heat Q, mass into succeed constant volume, rise of temperature. What is T1? Initial temperature. What is T2? Final temperature. What is mass? M, mass of gas in kg. So what is value of Cp and Cv? Clear? For air, what is Cp is equal to 1.005 kilojoule per kg Kelvin, and Cv is equal to 0.7128 kilojoule per kg Kelvin. Gamma is equal to Cp minus Cv. What is Cp by Cv? 1.4. Clear? What is R is equal to Cp minus Cv. What is value? 0.287 kilojoule per kg Kelvin. Make minus 7 9 2 8, ठीक है. Clear? This is value of Cp and Cv and gamma and R. The value of Cp, Cv, gamma and R for air. Next, temperature. I told the temperature is intensive property because this is independent of mass of the system. Clear? It is an intensive thermodynamic property. Thermodynamic property which determines the hotness or coldness of the body. Clear? A body is hot or cold. That depends by temperature. So, a body is hot or cold, this defined by temperature. A high temperature intensity. Suppose the body is at high temperature. It is said to hot. Low temperature intensity. A body is at a low temperature. Cold body. That is hot body. Clear? It is measured. It is measured by an instrument. By an instrument called thermometer. Clear? Thermometer. So the relation between different scales of temperature. Clear? The relation between the relation between different scales of temperature is C by 100 is equal to F minus 30 by 180 is equal to R by 80. Clear? 25, 9, 4 divided by 20. This is C by 5 is equal to F minus 30 by 9 is equal to R by 4. Clear? Where C is equal to temperature in centigrade scale. Temperature in centigrade scale. Clear? What is F is equal to? F temperature in Fahrenheit scale. And R is equal to temperature in Reaumur scale. Clear? What is Kelvin? What is Kelvin? Kelvin is equal to degree centigrade plus 273. Clear? When we are doing problems, the question given centigrade. So convert the centigrade by adding 273 and make that Kelvin. Clear? So suppose temperature 15 centigrade. So this is equal to for 15 degree centigrade. What temperature T is equal to? 15 plus 273, 280 Kelvin. Clear? So the question is given at 15 degree centigrade. Then make that temperature into Kelvin by adding 273. That is 15 degree plus 270 is equal to 288 Kelvin. Clear? Next class I will do what is heat, work, equilibrium, pressure, different this. Okay? You follow this and please make like, share, subscribe. This is your first class in thermodynamics, engineering thermodynamics. Thank you.